the common area, because everything is shaded in this region, it means that this area represents those x1, x2s which satisfy all three constraints. Every constraint is satisfied by these x1s and x2s. Now, we want to check the value of the objective function at these x1s and x2s, but we want to make sure that we check them only on the points of intersections. So beta, now I will start making a curve. So this is, these labeling the points. This is O, this is A, this is B, this is C, and this is D. So we need to find out the values of x1 and x2 at each of these points, at 0 or A, at B, at C, at D, and at these points. Achha, now just have a look here. But look that if I talk about the point O, तो यहाँ पे तो मेरा x1, x2 are 0, 0 only. If I talk about the point A, then here I can clearly see from the diagram itself that my x1 is going to be 0 and x2 will be 25. This is easy. Leave B and C for now. Come to D. So you can clearly see that D is given by x1 as 22 and x2 as 0. This is just coming from that curve. Now look at point B. But this is my first constraint that we had plotted. This constraint was the flour constraint, right? This is my second constraint that I had plotted, and this constraint was the sugar constraint. And this is the third constraint that we plotted, and this constraint was the butter constraint. Now look at point B. At the point B, this butter constraint and this flour constraint are intersecting with each other. So which two equations will I solve? I will solve the equation of the butter constraint with the equation of the flour constraint. So let us just go back into this. So my flour constraint is 3x1 plus 6x2 is equal to 150. And I need to solve the flour constraint with which one? I need to solve the flour constraint with the butter constraint. So my butter constraint is x1 plus x2 is equal to 27.5. These are the two constraints I have. Two equations, two variables. I can solve them simultaneously and get the value of x1 and x2. So if I just go ahead and I do that, from here, beta, I will get x2 is equal to 27.5 minus x1. I will put this x2 in this equation. So 3x1 plus 6, 27.5 minus x1 is equal to 150. 3x1 plus 6 into 27.5 minus 6x1 is equal to 150. So I am going to go ahead. Let me just quickly calculate this thing. So 27.5 into 6 is going to give me 165 minus 150 is equal to 3x1. So x1 will be 15 by 3. That means 5. And beta x2 will be 27.5 minus 5. That means 22.5. So I will get this as 5, 22.5. Now I need to look into the constraint C. So if I look into this intercept C. So if I look into C, what do I see? I am seeing that one, I have the sugar constraint, and other constraint that is meeting is the butter constraint. So at point C, there are two constraints which are intersecting. One is the sugar constraint and one is the butter constraint. So I need to solve these two equations simultaneously. So if I just go back, my sugar constraint is x1 plus 0.5 x2 is equal to 22. And my butter constraint is x1 plus x2 is equal to 27.5. So I will just subtract and I will get 0.5 x2 is equal to 5.5. This is what I will get. So beta, now you can just go ahead and solve the value of x2 from here and x1 also. So what we are seeing in this case is that we are just solving these equations simultaneously. And when we solve them simultaneously, we are able to go ahead and get the solutions to these equations. So this is what I have gone ahead and done here. These are my feasible points. These are points A, B, C, these all points. These are found by intersecting, by seeing where they are intersecting with each other. Now, once I have got these points, my next aim is to go ahead and see the value of my objective function at each of these points. So now what did I want to maximize? The revenue of this baker. What is the revenue of this baker? The revenue of the baker is 20x1 plus 30x2. So what will I go ahead and do? I will write down the revenue of the baker as 20x1 plus 30x2. And beta, I am going to go ahead and I am going to put each of this value in this. So 20 into 0 plus 30 into 0, 20 into 0 plus 30 into 25. ऐसे करके एक x1 or x2 you will plug in here, right? So here also you will do 20 into 5 plus 30 into 22.5. So when you will go ahead and when you will keep plugging these values, you are going to get these values. You will get these values. And you will see that the maximum value that you get, it is at point B. B point B. At point B, you will see that you are able to get the maximum value of the objective function. And that maximum value is coming as 775.